All right, all welcome to the Phenomenal Science Teaching webinar series. Today I'm your presenter, Vic Sampson, and our moderator is Jill Gregory. We're presenting here, while I'm presenting here, Jill will be watching over the chat and that kind of stuff. So if you have any questions, we can respond to those as you need them. Don't forget, by attending these webinars, you can earn 0.5 credits, CEU credits per session. And if you attend all of them, you get 6 credits for all of these. So make sure you attend, and so we can give you those credits for you, something helpful as you move through the year. A quick reminder, structure of the webinars. We are trying to keep these kind of short and targeted because I know everybody has a limited amount of time. So we'll spend about the first 20 minutes or so talking about the topic, and then we'll have about 5 minutes or so for questions, and then we'll do wrap-ups and announcements and prepping for next time. As always, these are recorded, so if you can't make one, and if you registered, we will be sending you a link and a copy of this so you can see it as well. Although you don't get to do questions that way, you can still get the presentation about the topic. So let's get started today. In this seminar, we're going to be talking about recurring themes and concepts in the new Science TEKS. So I mentioned them briefly in our last ones, and you can think of recurring themes and concepts are just ideas that bridge disciplinary boundaries, right? So you see them whether you're studying biology, chemistry, physics, earth space science, or even engineering. So you can kind of think of them as defined that way. And in the new TEKS, we have several different ones that we can see, right? So we've got one of the big recurring themes and concepts is patterns. So regardless if you're in life science, physical science, or earth space science, you see scientists observing patterns in nature to kind of guide organization and classification systems. They also generate questions and help people try to figure out the underlying cause of those patterns. Now, in addition to seeing patterns in nature and those around us, trying to understand how patterns make sense and what those mean is a big part of kind of data analysis and making sense of observations. So on the screen here, you can see different kinds of analyses that are doing. So these are all examples of patterns as well, and they indicate different things about what or how is happening in the world around us, right? So if you think about something changing or increasing in number over time, that could tell you that's a pattern that you can look for, or how a number of one thing is related to a number of another thing, right? And these relationships can have different kind of positive or negative or no relationship together. We could also think there's types of things and the numbers of those, and the numbers of different types often form patterns, and then we can use that to help explain. And then there's covariation, right? So there's ideas that when you're looking at different things, they may have a feature, may not have a feature, or they're here together or not together, and those kinds of things. And finding those kinds of patterns as well is a really big part of making sense of the world around us, right? So this happens regardless of discipline, but you see patterns over and over again. Another major recurring theme, some would argue one of the major goals of science is to understand cause and effect, right? So thinking about to identify causal relationships, whether it's life science, physical science, or earth space science, right? So thinking about how when we see a cause, what leads to the effect. Now, what's important about that is the thing that scientists are really curious about is mechanism, and mechanism is often unseen. So, for example, in life science, you may see a cause of, if you take a plant and you add water to it, over time you'll get a larger plant, right? So that is a relationship, a cause and effect relationship you have, but the underlying mechanism of why adding the water to the plant leads to more growth is one of the heavy lifts of science, and these mechanisms are often unseen and have to be tested by different ways. Another big recurring theme that we often see is energy and matter. I can think of that as flows, cycles, and even conservation, right? So one of the things that scientists are doing regardless of discipline is really understanding how energy, first energy flows into, out of, or within a system, and then coupled with that matter, right? So for life science, if you think about ecosystems, how does matter move from plants to animals, right? or energy moved from plants to animals in that ecosystem, right? Physical science, thinking about how energy is added to a system like a pot of water and what that does to the components of that system, like the molecules. Or space science, understanding energy budgets, how things maintain temperatures when they're exposed to light or not light. Those kinds of things are a major goal and role that you see across all of these different disciplines. Another big one that we see in our new TEKS is called scale, proportion, and quantity. So one of the things that scientists have to be able to do is they have to make a lot of choices about where to look and how to measure, right? So when we talk about scale, we talk about the very large or the very small. And depending on what you're studying as either small or large, you will have to focus on different aspects of those, that phenomenon, right? Then thinking about quantity as well is also how do we measure that and which measurement scale, right? So scale comes up multiple times. We also think about proportional relationships, not just absolute, one-to-ones kinds of things. Thinking about how this affects this, or this is divided up between categories or groups, right? But you see scientists thinking and talking about scale, proportion, and quantity throughout the different disciplines. Another big recurring theme that we'll find in our new TEKS is called stability and change. And this is the idea of making how, when we look at a system or a phenomenon, what makes it stable, consistent, or unchanging, and then what causes it to be unstable and change quickly, and what controls rates of how things are changing, right? So if you think about in life science, that may think about the health of a plant and how does that plant stay healthy until it reaches a certain temperature, which causes it unstable and start dying, right? Thinking about how things change, melt, change temperature, change states, right? All of these different kinds of ideas that come up in terms of change and constant, and even when there is variation, what keeps something from crashing or growing out of control. Another one is structure and function. Structure and function is very common. We think about how the structure of an object determines its functions and also puts limits on what an object or an organism can do. For example, if you think about in life science, the structures of living things determines where they can survive, how they find food, what they eat, what different environments they can take up. If you think about that from a physical science lens, what we choose to make objects out of or paint things out of changes how it interacts with light and what kinds of functions it has. Earth-based science, you think about all of the different earth materials, where they're found, what they can do, why we have to rely on certain different kinds of materials to do different kinds of jobs, or make certain kinds of things in the technologies that we create. All of these come up of this issue of between structure and function. And it's not only natural, but also the constructed or the manufactured, of thinking about how structure and function plays a role in those. Another big recurring theme that you'll find in the new TEKS is systems and systems models. So we often think about systems, right, and defining what the boundaries of those systems are. So what's inside or what's outside the system, and then thinking about how we can use models to represent what's going on in that system. And the idea behind models is they're tools to help us understand what is happening. And these can be physical ones, conceptual, or mathematical in any number of ways. And the idea is they're tools to think with when we're thinking about system models. Now, one of the big things to think about this is not only do we have these new recurring themes and concepts in there and understanding what they mean, but it's more important to really, I think, to think about how they can be used as an organizational framework for connecting knowledges, right? And from the various disciplines, and more importantly, making sense of the things that we see. So I showed you all that I've attended earlier ones, this graphic, and it's this idea of three-dimensional science. And when you think about these three dimensions, which are all found in the new TEKS, is you've got kind of these three categories. Is the first one of being disciplinary content, and these are the models, theories, and laws. This is kind of our starting point, right? So what do we know already? And we can use that to either explain or design, right? Then there's the science and engineering practices, is what's the things that we do to generate new knowledge using that content. And then finally, there's the recurring themes and concepts. And I think this is where they get most valuable, is when you think of them as a lens or a framework and helping you decide what to pay attention to or focus on when you're engaging in these practices and using disciplinary content to make sense of something new. Let me give you an example of what that may look like. So I'm going to show you a quick video here. When you look at this, I'll let you watch this here and you can see this. So people see the magnets move or hover above each other or change distance from the bottom of the pole, and it starts generating questions. Well, why is that? Where the recurring themes become very useful for people is thinking about that in terms of what patterns do I see? Is there what causes the magnet to move closer to the bottom of the pole? How can I measure the quantity of movement, and which scale should I use? Can I create a model of the system to help understand what's going on? Does the height of the magnet stay stable or change over time, and why? Here's another example. So instead of just saying what's going on, right, we can use the recurring themes and concepts to think about what we need to pay attention to, right, and design investigations around that. So what causes some but not all of the water to change from a solid to a liquid? How can I measure the quantity of the water that changes from solid to liquid, and which scale should I use to do that? What type of models of the system could I make to help understand what's going on? How can I track the movement of energy into, within, or out of this system? How can I measure the quantity of energy that moves into the system, and which scale should I use? Does the size or shape of the object, which is a structure, affect how quickly the object melts the ice, which is its function in this case? Right? So these ideas become really useful of organizing and help you determine what to pay attention to when designing an investigation, so it's less of a just investigate anything. Another example for you. So when you watch this on the left, you start seeing the ball of dough increase in size, right? So what patterns do I see? I see slowly decreasing and then more rapidly. Well, why is that? What causes it to grow? Can I measure, what should I do to measure the quantity of dough growth? Which scale should I use for that? Can I create a model of the system to help me understand what's going on? Once again, how can I track the movement of matter into, without, or out of the system? Do I count the bowl? Do I count the dough? What's about the plastic? What's inside? What's outside? What's the boundaries? Does the change of dough stay stable or change over time, right? Is it a consistent change in size, or is it speed up and slow down over time? And if that's so, why? Many, many different things. One last example. So as we watch this, once again, what patterns do I see? In sequence of events, does something always happen or precede something else from happening? Or precede something else, or always happen that, or must come afterwards? Is there a range when only things happen? What causes the water to change color? What causes it to change temperature? How can I quantify the change in color? What scale should I use to do that? Can I create a model of the system, once again, to help me understand what's going on? How can I track the movement of matter into and out of this system? It's on a hot plate. Can I also think about the energy? Does the change in color stay stable, or does it change without adding something new into the system? Or does it, and why? Does the change in temperature stay stable over time, and why? There's so many questions that these recurring themes and concepts can help us make sense, we can use to help make sense of the things that we see in more scientific ways. So one of the big takeaways I always think when we think about the recurring themes and concepts that are being added to the new TEKS is that we should view these as thinking tools that students can use, and helping them realize that these are tools that they can use to help guide the way they make sense of things, make sense of the phenomenon they see around them, rather than just another thing for them to define or memorize or identify. And that's really the big heart of this, is that seeing these recurring themes as a lens or a tool is really useful for kids, and then just structuring lessons that give them opportunities to use them as a tool, rather than just spending time saying, well, these are the different recurring themes. Please define what they mean. I will ask you to identify examples of them on an upcoming test. So with that, that's kind of the big idea about the recurring themes. If you have any questions or anything, you can post those in the chat right now, and then we can answer those. And Jill, please call those out if we have any.
Tracy says, thank you for the demonstrations.
You're welcome, Tracy. Very kind of you. Yeah, it's interesting when you start thinking about how useful these ideas become, right? And I would say a very useful thing is to look at a phenomenon like those videos that I showed you and try to ask a question around each of those recurring themes. And based on those questions, it really does help you kind of key in on things that you can look at for and investigate and start thinking about in terms of designing and carrying out better investigations, right? So instead of just having someone say, well, why does it do that? Or how come? Or that's cool. You can really start kind of keying in. And it also drives home to me the idea that really understanding any phenomenon requires many, many different kinds of investigations, right? Like there's many angles that you can look at when doing this. We can take an energy perspective, we can take a structure and function perspective, and then that shapes what data you collect, right? How you make sense of the data that you do have, all of those different kinds of pieces. So it's really kind of a useful, for me it was when I started thinking about that, I was like, oh, that's really helps me make sense of something new. So I really think they're useful thinking tools. I'll go ahead and wrap this up here. Just for quick reminders of our next ones coming up. So these are always on Thursdays, this series. So in February, we're finishing up January. I can't believe the new year is moving this fast. But in February, we will have 5 different webinars. On the first, we'll be talking about science and engineering practices, right? Defining what those are and what those look like, and thinking of more of as tools to use to make sense of the world. Then we'll talk more about phenomena, and especially how to choose phenomena to organize instruction around. Then we'll talk about 3D instruction. So once you've introduced a phenomenon, how do you go about getting kids to use these ideas and recurring themes and practices to make sense of that phenomenon? We'll spend some time on the 22nd talking about assessments of more than testing vocabulary, but testing students' ability to use these 3 dimensions, and what does that look like and how those assessments are different. Then on the 29th, we'll kind of circle back again and talk about how to introduce phenomena so it creates a need to learn, rather than just giving an example in the everyday as an example of things that we are teaching about. So that's February, and then in March we'll be talking about how to foster learning more after introducing a phenomenon. We'll be talking about promoting and supporting student talk, because that's a key part of where we're going, and then also supporting emerging multilingual learners in science. So once again, these are at 4 to 4:30 on Thursdays. You can register at that website. Jill will also drop that into the chat, so you can do that. Please feel free to pass it along if there's any other teachers at your school of like trying to get their or need to dig into the new TEKS and start thinking about this 3-dimensional instruction and what that looks like. This is a great way to kind of start thinking about that and get started. So welcome you all to join. Also, if you can't make it, just sign up and we'll make sure we send you the video so you have it, so you can catch up on your own time. Also, if you're interested in any other professional learning opportunities, check out our event calendar. So if you go to this page here, this program's events, we try to put a calendar up there that'll talk about upcoming events that we are doing. It has all the different webinars, so you can plan ahead. We'll be starting another series on Tuesdays as well. So we'll have Tuesdays and Thursdays. They're focusing on different topics, so you can choose one or both and all others as well. You can also go to our professional learning page. That's there as well. You can kind of look at those and kinds of other offerings we provide. So hopefully we're here to help you best we can as you navigate these new TEKS and think about teaching with phenomenon more. If you have any questions for me, especially if you're watching this video and weren't able to attend live, feel free to email me at victor@argument-driven-inquiry.com. That's right there. Also, if you get active on social, we have X, Twitter, whatever you want to call that, Instagram and Facebook. We all have pretty active communities on there of other teachers that are teaching this way and talking about those stuff. So please join those. It's a great way to kind of interact and get your questions answered as well. So with that, we're going to wrap it up today. Thank you again so much for joining us, and we will see you next week. You can contact me with any questions, or if you want to talk about anything, I can also point you towards some useful resources, whether that's reading stuff like I threw in the chat here today, or simpler articles, or if you just want to have a chat about these things, I'm here to help in any way possible. So hopefully I'll get a chance to see most of you all next week again. And like I said, we're going to be talking about recurring themes. What are those? They're more than just concepts. So all of those kinds of things, right? So Joanne, that's a great question. How do we know what tools we'll need for 3D learning? Send me an email real quick and I'll talk you through that, because that is going to be a little bit of a longer question to talk about that on that kind of stuff. So thank you so much, everybody. It was great to see you. Hopefully see you next week again. Thanks all.